Last time we learned about the squeeze theorem. The squeeze theorem tells us if there are two sequences, A and C, which bound the sequence B, when the sequence is large enough and term is large enough, and if the upper bound and the lower bound converges to the same number, so limit an and limit cn are the same, and that number is L, then the sequence in the middle converges to the same number L. The consequence of that is if the sequence absolute value converges to 0, then that sequence converges to 0. Why is that? Because the sequence an is stay in the middle of negative an and an. So I would say that absolute value of negative an and the absolute value of an. Let's do some application problem. Though the application problems are not about squeeze theorem's application problem, the application of the theorem, which I stated before, determine whether the sequence converges or not. The first problem is the sequence an is defined as 1 plus minus 3 over 7 to the n power. We consider limit of absolute value of negative 3 over 7 to the n power. And then that is limit n goes to infinity, 3 over 7 to the n power, which is just forgetting the negative sign. What we know is this fraction is less than 1. And so when we increase the power, that number converges to 0. That means limit n goes to infinity, negative 3 over 7 to the n power equals 0. So now we applied this theorem, which was the application of the squeeze theorem. And limit n goes to infinity, the original sequence 1 plus negative 3 over 7 to the n power. And then we can separate the limits. So limit n goes to infinity, 1 plus limit n goes to infinity minus 3 over 7 to the n power. And so this is the constant number. And when we consider this as a sequence, all the numbers in the sequence are one, the same number one. So limit goes to one, and this goes to, the second one goes to 0. So that is 1, right? If it is possible, if you can activate your camera, then I will appreciate if you activate your camera. The second one is an equals -1 to the n power over square root of n. We think about limit n goes to infinity -1 to the n power over square root of n. So in this case, when we forget the sign, we have 1 over square root of n. So as n goes to infinity, 1 over something will go to 0. So the limit goes to 0. So that implies when limit n goes to infinity, -1 to the n power over square root of n equals 0. Next theorem is if limit n goes to infinity, an equals L, and the function f is continuous at the value L, then limit n goes to infinity, f of an equals f of limit n goes to infinity, an. So that means the function value at L. This is an. So that basically means there's two sequence. The one sequence is defined in the domain, and the other sequence is using the function value. When we think about the limit, we can take out limit if the function is continuous. Let's see how that can be applied in the circumstance. Determine whether the sequence converges or not. So an is tangent of 5n pi over 3 plus 20n If you just look at the sequence, it is really hard to think about anything. So what we want to think about is we want to think about this fraction, the input sequence. And we want to consider the function property of tangent. So let's consider the function f of x is tangent of 5x pi over 3 plus 20x. Then limit x goes to infinity, 5x pi over 3 plus 20x equals what? Limit x goes to infinity, 5x pi over 20x. Why is that? 3 is extremely small if x becomes huge. So we can forget this small attachment. So these two will cancel each other. So that becomes limit x goes to infinity, 5 pi over 20. There is no such x, and 20 is 5 times 4. So 5, these two 5 will cancel each other. So that becomes pi over 4. So when we apply the previous theorem, what will happen will be when we evaluate limit x goes to infinity, tangent of 5x pi over 3 plus 20x. That equals tangent of limit x goes to infinity, 5x pi over 3 plus 20x. So that means tangent of pi over 4. So we are considering 45, 45, 90-degree triangle. And this is opposite, and this is adjacent. And so tangent of pi over 4 is 1 over 1, which is 1. So answer to the question is 1. Any question? Second question is an equals cosine of 4 over n. We consider the function f of x equals cosine of 4 over x. And then we will consider the limit of the input and then limit of the output. Let's consider the limit of the input first, then limit x goes to infinity, 4 over x, that equals 0 because x goes to infinity and the numerator is a fixed number. So x goes to infinity, cosine of 4 over x is cosine of limit x goes to infinity 4 over x. So that means cosine of limit x goes to infinity 4 over x, this input approaches 0, so that equals 1. So limit n goes to infinity, the answer to the question is 1. Where the function approaches is the same as the sequence approaches. The next problem is an equals 1 plus 4 over n to the n power. In this case, we will convert that into the function. Then f of x equals 1 plus 4 over x to the x power. But we want to evaluate that implicitly by considering the natural log on both sides. So we put natural log of f of x on both sides. Then natural log of f of x is natural log of 1 plus 4 over x to the x power. So that is natural log of f of x equals x times a natural log of 1 plus 4 over x. We have to evaluate the limits. So we will take limit x goes to infinity, then natural log of f of x equals limit x goes to infinity, x times natural log of 1 plus x 4 over x. That equals x goes to infinity, natural log of 1 plus 4 over x over 1 over x. So that is because this one goes to infinity, and what is this? This one, this part goes to 0 when x goes to infinity, and the natural log of 1 is 0. So that is infinite times 0 form. So when we evaluate we will have to use a trick, because we cannot say any number times 0 becomes 0, because it diverges to infinity. So we put natural log of 1 plus 4 over x over 1 over x. By doing this, what we are doing is we want to apply the L'Hopital's rule. So we have limit x goes to infinity. This one is minus 1 over x squared. And for this part, we have to use chain rule. So 1 over what's in the input, so 1 plus 4 over x times we have to differentiate this part. The first part will vanish and the second part will become minus 4 over x squared. So what can you do this? So this one is in the denominator. So we can multiply that as reciprocal here. So let's copy what's in the numerator. That is 1 over 1 plus 4 over x times negative 4 over x squared. And minus, we flip it, x squared over 1. So this x squared and this x squared will cancel each other, and minus minus will make plus. Therefore, we have x goes to infinity. The numerator is 4 over 1 plus 4 over x. So when x goes to infinity, 4 over x goes to 0, and so that becomes 4. Any question? All right. Then what we evaluated was limit x goes to infinity, natural log of f of x. And that equals natural log of limit x goes to infinity, f of x. That is 4. That's what we obtained by calculating. So as we had written down here, natural log of limit x goes to infinity, f of x equals 4. So what does that mean? That means limit x goes to infinity, f of x equals e to the 4. So natural log of a equals natural log base e of a. When that equals b, that is equivalent to a equals e to the b. That's what is going on here. So that means limit n goes to infinity, 1 plus 4 over n to the n power is e to the 4 power. Any question? Next problem is an. The sequence an is natural log of 3n over natural log of 6n. For this question, you don't cancel ln and ln, or you don't cancel do anything with 3n over 6n. You cannot combine these two natural log of 3n over 6n. But what you will use will be natural log of a times b equals natural log of a plus natural log of b. This is the property we will use. So an equals natural log of 3n over natural log of 6n. So what we can notice from here is 6 is 2 times 3. So inside of here, the input is 2 times 3n. So what we will do will be we will rewrite that as natural log of 3n over natural log of 2 plus natural log of 3n. So what we want to do here is we want to divide by the highest growing term in the denominator. So 1 over natural log of 3n here, and 1 over natural log of 3n. So what does that mean? So these two will cancel each other, and 1 over, we distribute like this, and then natural log of 2 over natural log of 3n plus this one will cancel each other, plus 1. So this one goes to 0 because this is the natural log function. Natural log of x equals y. So when x becomes larger and larger, the y becomes larger and larger and increase forever. So denominator goes to infinity, and then whole thing will go to 0. So the entire fraction will go to 1. So basically what we did was limit n goes to infinity. Other easier way to think about this problem is limit n goes to infinity. An can be still written as limit n goes to infinity, natural log of 3n over natural log of 2 plus natural log of 3n. And then what we notice is the logarithmic function is an increasing function. And so this goes to infinity and this goes to infinity. And this is a finite number. So when those are growing indefinitely, this is almost nothing, right? So we can ignore that. So we can put equality with a natural log of 3n over natural log of 3n. So that is 1, right? Limit 1 is 1. You can go either way. Any question? So the next one is limit n goes to infinity, natural log of n over n. So limit n goes to infinity, natural log of n over n is the same as limit x goes to infinity. We want to use the function property, natural log of x over x. So after we convert that to the function form, we can apply the L'Hopital's rule. So that is limit x goes to infinity. The denominator, the derivative of the denominator is 1, and the derivative of the numerator is 1 over x. So that is limit n goes to infinity, 1 over x. So this gets larger and 1 over something becomes smaller, and so it becomes 0. Any question? Let's keep doing that. The next example is evaluate the limit if it exists. The first problem is an is 7 plus 5 n squared over n plus 4 n squared. There are two methods to do this. The first one is the best known method, which uses a straightforward method. We divide by the highest growing term in the denominator and to the denominator and the numerator. And then we can do distribution separately. Then we have when n goes to infinity, it becomes this one times this one will make 1 over n, and this one times this one will make plus 4, and this one times this one will make 7 over n squared, plus this one times this one will make 5. So when n goes to infinity, those two terms will go to 0. And so that is 5 over 4. And then we want to think about more intuitive method. Limit n goes to infinity, 7 plus 5n squared over n plus 4n squared. What's going on here is what we have been talking was when we consider this type of fraction, if there is a constant number, then, and when n grows to infinity, the constant number is relatively too small, so we can ignore that. The same thing will apply to the lower degree terms. So for lower degree terms compared to the higher degree term, contribute to the entire fraction a very small amount, extremely small amount when n goes to infinity. So when we compare this number and this number becomes almost nothing if n is very large. So that means these two terms, the lower degree terms, can be ignored, and we can just look at the higher degree terms ratio. So that means the limit will go to the 5n squared over 4n squared, which is 5 over 4. Any question? The second one is an equals n cubed over 6n plus 5. Limit n goes to infinity, n cubed over 6n plus 5. This is the classical method many of you have been using. So as we discussed, we will just divide by the highest degree term in the denominator and the numerator. So that becomes limit n goes to infinity. The denominator becomes 6n over n, which is 6 plus 5 over n, this one, and that is n cubed over n, which is n squared. So n squared here. So what's happening here is that when n goes to infinity, this one goes to 0, and the numerator goes to infinity. This becomes smaller, and the numerator becomes larger and larger. The entire fraction will go to infinity. Limit n goes to infinity, n over 6n plus 5. Let's proceed with the method I was teaching you. We can ignore the smaller degree term in the denominator and numerator, and we just focus on the highest degree term in the denominator and numerator. Then what will happen will be the limit will be the same as n cubed over 6n. So that means limit n goes to infinity, n squared over 6. So n squared goes to infinity, so that will go to infinity. Any question? Let's do one more problem. The next problem is limit n goes to infinity, n over square root of 10 plus n. We will just do the two different methods, one classical, other one intuitive. So in this case, when we try to divide by the highest degree term in the denominator, and then we have to divide by 1 over square root of n to the numerator and denominator. Then that becomes limit n goes to infinity. When we multiply them together, it becomes n over square root of n over square root of, just all things will be put into the square root. And so 10 over n plus n over n. So when n goes to infinity, this 10 over n will go to 0. So limit n goes to infinity. In the denominator, the under the square root, this one will be 1. And this one will be square root of n. So square root of n. So square root of n will go to infinity when n grows indefinitely. So that is infinity. So that diverges. Method 2 is much more intuitive. So limit n goes to infinity, n over square root of 10 plus n. So basically what you're just doing is a degree of the numerator is larger than the degree of the denominator, then it should diverge. But when we clarify a little bit further, it goes like limit n goes to infinity, n over 10 is a fixed number, and so we can ignore. And so we can say that that's almost the same as square root of n when n is extremely large. So n equals square root of n times square root of n. So those two will cancel each other. So we have the same conclusion. Limit n goes to infinity, square root of n. So that goes to infinity. Any question about what you learned today? All right, and that's all for today, and see you tomorrow. Mm-hmm.